Hi there! Today we are going to review the Anet ET4 3D printer. So let's get to it. Welcome back. So Anet sent me this printer about 2 months ago and asked me to use it, and if I liked it I should share my opinion with you guys. They didn't pay me, they just sent me the 3D printer. And before we get to the actual printer, let's see what makes a good 3D printer. I'll show a diagram on the screen. In my opinion, 3D printing has 4 different stages. The first stage is the software that you design your model in it. In my case, I use Fusion 360. After that, you use what's called a slicer program, like the Cura, to slice your model into a G-code that your printer can understand. Third, there's the firmware and the control board in your 3D printer. That's essentially your 3D printer's brain that utilizes G-code and commands the hardware that's included, heat and the movements of the motors to create the model. Fourth, there's the hardware that should be capable enough to utilize the demands of the control board. So we established that there's 4 stages in 3D printing, and a 3D printer is responsible for 2 of those stages. In the case of Anet ET4, there's a very good hardware, all metal constructed, the plastic parts are all injection molded, and the assembly only requires 6 bolts and the tools all comes in the packaging. But the firmware and the user interface, it's not open source, and its lack of customization and calibration really ruins the printer quality. Luckily, a while back, Anet came up with the open firmware for their machines, but you need a T-Link to install Marlin 2.0 on these. I'll be explaining that in another video, but for now it's closed firmware and you can't calibrate anything, and the only customization that you get is the heat. You can adjust the heat of the nozzle and the temperature of the bed, and that's it. Okay, here we are. Let's check out the models. At first, we have the 3D Benchy, and it looks great, except for the small overhangs on the doors. The rest of the model printed beautifully. Every detail is printed nicely and looking good. Now we have this octopus, and as you can see, it failed at the top. What I think happened is that the extruder jammed, because I had the speed on these 2 way faster than the rest of them. These was printed at 70 millimeters a second, and the extruder just couldn't keep up at the head and jammed. But the rest of the model looks great. I mean, the eyes, eyebrows. We do have some artifacts on the legs right there. It's on all of them, so I would say it's because of the very fast speed, but it looks fine. Now next I started printing calibration cube, and as you can see, there is a lot of calibration cube here. So I printed this one first, and its measurements came out on the X, came out 20.03 millimeters. On the Y, it came out 20.07 millimeters. They both were very, very accurate, but the problem was the Z-axis. As you can see, it printed out 19 millimeters, a whole millimeter lower than it should have been. So I thought that because of the elephant foot artifact that you can see down here, I thought that I have set the bed temperature too high, and that was the issue. So I printed another one, and it had the same problem, and the measurements came out 19.2 millimeters. So I decided to print it on a raft to account for the heat, and I wasn't able to take the raft off, and well, that failed. So I decided to go with a cold bed, and that didn't finish at all. It shifted at the end, and that failed. So after further investigation, I realized that the heat wasn't the problem. I have set the extruder head, the nozzle, too close to the bed, and it would squish down the first layer of filament too much that it would wreck the Z-axis accuracy. So after leveling the bed a lot of times, I got up to 19.8, which is way better than the 19 that we had. And at the end, I got it the same 19.8 that we had on that one. So yeah, that was my mistake, not the printer. Of course, if it was possible to calibrate the ZStops on the firmware, which is Anet's own firmware, it would have been more accurate, but here we are. Then we have this 3D printer mini test. The overhang test, they all successfully printed, but as you can see on the underside, on the 80 degrees, it didn't look good that much. So I wouldn't count that as successful, but the rest from 75 to lower, they all printed very well. The stringing test between these small posts, they look good. There isn't much stringing, there is a little bit down there, but the upper side looks good. The bridging test completed on all levels, and it looks good. And the walls on these two, they both measure out. They are supposed to be 1 millimeter thick, and this one measures out 1.10 on the slimmest side. So that's about 10%, and I think it looks good, but it could be better if it was possible to calibrate the ZStops and on the printer itself. So yeah, we have the test. Next, I had to do it. I printed this spiral vase and it looks great. This was created in vase mode and at 60 millimeters a second without any problems. It looks great, and I don't think there was any problem with it. It's just beautiful. Moving on, we have this 10-inch vise in here. This was a 3-piece print. We had the screw, we had the jaw, and we had the base itself. The tolerances were done beautifully and it works really good. As you can see, the screw works and the tolerance in the jaw and the base was spot on. Next, I printed this ghost ship benchy to test how much detail can this printer handle, and this model is really not for FDM machines. This is really detailed and small movement that it didn't work out well, but still the surface finishes on the doors and the roof and on the sides, they look good. The skeleton teeth looks a little messed up, but that's fine. I didn't really expect this printer to complete this print. I just wanted to test it. Next up, we have this coaster, and I wanted to test how fast this printer can go. This was printed at 100 millimeters a second, and as you can see, it did produce some artifacts on it, but it does look good and it's more of a functional print. It really doesn't matter how much good it looks. So yeah, I think that looks fine. And at the last, we have this virus stripper, and I wanted to test to see how easy this nut will fit in here. So they didn't fit that well. I had to heat them up and push them in place, but the print looks good. This was printed at 60 millimeters a second. I'll show the print parameter somewhere around here. And yeah, that looks fine as well. Okay, and the last model, we have this crocodile, you know, what thing that can hold it. I printed this to see how the tolerance can be handled on this printer, and they were good, except that I again set the heat on the heat is a bit too high. It was at 60 degrees, I think, and it melted the first layer and fused them together, so it was really hard to separate them in this place, but the rest, it works really good. Okay, that was the models, and let's go to the printer itself. Now the spec on this printer is the build volume is 220 by 220 by 250 millimeters. The temperature of the nozzle reaches 250 degrees and the bed goes up to 110 degrees. That is really good. It has a Bowden style extruder. It's not double geared, it's single gear, but it binds the filament really good. I rarely had any issue with it. It has a filament runout detection sensor and a power loss detection. So if your power goes out, the printer can continue the print, and if you run out of filament, it can continue the print. It has an LCD touchscreen. It uses micro SD card, and you can connect it via USB to a computer. It's really quiet. I don't have any problem with it. It has auto bed leveling, but I found a strange problem that when it is auto bed leveling, if you stop it at the middle of the operation, it makes a weird noise and shows a bunch of random numbers. Let me show you. Oh, crap. The thing that I like about this printer compared to the older version is the ZStop. You see, the older version had a micro switch up here, and it would, for homing the printer, it would go all the way up there to home the printer. But this one doesn't have a Z switch. It uses the auto bed leveling sensor and the bed to home the Z axis, and that's really good. So we have the front screen here. From right, we have settings that you can move the axis around or home the 3D printer. Then there's info. It shows you the model, the version, the build volume, company, and website address. There's the upgrade, which there's no SD card in there, so it's not showing anything. Then we have prepare, that you can preheat your machine. You can change your filament. It can be in various speeds. And you can level your printer. We have manual and auto bed leveling. And there's the print, which shows you your models. And in the language we have Chinese, English, French, Spanish, and I don't know the other two, sorry. There's for the user interface, as I said, it's pretty simple and you can't really calibrate anything. Let's move to the printhead. Here's the printhead that includes the auto bed leveling, the extruder cooler, and the part cooling fan, which blows air only from one side, but it's pretty fine. The printer uses via slot, and you need to adjust these wheels on it so it can move freely. And let's move on to the extruder. Okay, now here we have the extruder assembly and the extruder stepper motor. We have the filament runout detection and the Z and Y axis cable. That's only this thick flat cable, which is awesome by the way. It makes wiring very, very easy, and all the wires are labeled really nicely, you can see here. And that's about it. Overall, the Anet ET4 is a great 3D printer. It has a good price, it's well built, and it's easy to assemble. The only thing that I'm asking Anet kindly to do is to have an option in their website to choose to have Marlin 2.0 standard on the printer. That would be awesome. Alright guys, That's all I have. Thank you for watching, and I'll see you in the next video.